And welcome to another screencast. This one is Scheme for Sedimentary Rock Identification. Those of you playing at home or watching at home is page 7 in the Earth Science Reference Table. So first page here, second page, sorry. Take a look. You can see that, again, another pretty brilliant way to organize information. You can see that they classify igneous rocks as either being inorganic, land-derived sedimentary rocks, or chemically and/or organically formed sedimentary rocks. They classify them even further by texture, so something could be clastic or fragmental. And you can see that it kind of goes by grain size. Use the highlighter. Let's see, I like blue. Make it blue. So if we go by grain size, it's not very effective, is it? We go by grain size, we could see we could do pebbles, cobbles, boulders, embedded in sand, silt, and/or clay. Think about your sidewalks, what they look like. That would be an example of what it would look like. That's not actual sedimentary rock, that's fabricated rock. Could be sand, silt, and clay. So as we move down, the particles become smaller here. Kind of like moving away from a river, right, where it enters a large body of water. Then the chemically and/or organically formed sedimentary rocks also have a texture classification of crystalline or bioclastic. So you could see that limestone, I'm going to use a larger blue, let's see if that comes up better, let's see. That's much nicer. Limestone can either be crystalline or bioclastic. Another thing to note here are the map symbols. So if you're looking at a question and you see these patterns, you can actually look to see what type of rock you have based upon the map symbol. Alright, so looking at the next page. Let's see. So sorry, I exited full screen there for a second. If you look at our first sample here, it's conglomerate. And again, this is somewhat reminiscent of maybe your sidewalks. You might see pebbles and stuff like that embedded in concrete. But in this case, naturally occurring, it's pebbles, cobbles, and/or boulders embedded in sand, silt, and/or clay. And the important thing, this is conglomerate. It has rounded fragments. And that's what the map symbol looks like. And this would be considered a clastic sedimentary rock. And you'll often hear the phrase clastic sediments. Right, so these are all clastic sediments, which could be pebbles, cobbles, boulders, sand, silt, or clay. Clastic sediments cemented, or cemented clastic sediments. Next example is breccia. Right over here, there's breccia. You can see the map symbol. And the difference between conglomerate and breccia is, just believe it or not, just the way how the shape of the fragments. So angular, you can see that these are more angular, less rounded. Therefore, the fragments in breccia experienced less weathering and erosion compared to the ones found in conglomerate. Comparing them side by side, this one would be what? What do you think? Come on, a little bit louder. A little bit louder. A little bit louder. All right. You don't have to yell. This would be conglomerate, very good, and this would be breccia, based solely upon just the shape. And if you look, here's kind of the interesting thing. The composition could be exactly the same in terms of what it's made of, in quartz, feldspar, clay minerals, fragments of other rocks. So for all of these clastic sedimentary rocks, all of them could have the same exact chemical composition. The only thing that's different between them would be grain size. Moving on down the list, sandstone, which is nice. Sandstone is made of sand. Hey, what a great idea for a name for a rock. We have sand particles that get cemented together, giving us sandstone. You'll see samples of this in class. It's a very typical example of sandstone. You can see different layers because the sedimentary rocks form in horizontal layers. They form underwater. The sediments above push the water out below, and the minerals, when they dry, act like a cement, giving us sandstone rock. Siltstone, which is nice because it's silt, fragments of silt cemented together. They're very, very fine grained. That would be siltstone. And going on the list, you would think clay would be claystone, but nope, of course not. They have to be a little bit complicated and give you shale. So why they did that, who knows. So these are the clastic sedimentary rocks, clastic sediments cemented together. Various size. The different sizes will give you the different types of rock, and chemically they could all be identical. So if you take a look, this is a little bit blast from the past, a little stroll down memory lane, if you will, and you can see over here that sand matches up with sand over here, and look at the sizes. The sizes are the same Z, right? Maybe I should do different color. That'd be really cool. And then silt, right, would be this area over here, silt, so you could see the overlap. And then clay, of course, would be anything less than that would give me clay. See how the two reference table pages actually match up and they don't conflict each other, which is really cool. Now, if we keep moving down the list, we're getting into the first chemically and or organically formed sedimentary rock of rock salt. And if you look, it's composed of halite. You could look on the back of the reference table page to find some of these minerals in here. So there's the map symbol for rock salt. You have gypsum, rock gypsum, which some of you may have seen in the samples already, but we'll get into a little bit more detail about that. If you haven't, you will experience them soon, so it'll be very difficult to sleep tonight probably knowing that. Dolostone is made of dolomite, which would be the next rock on the list. Okay, and then keep moving on. Everybody's favorite, limestone. Limestone's pretty cool looking. You could see the shells here, and you could see that limestone could either be precipitates of biological origin or cemented shell fragments. And you could see this, the shell fragments, this would be the precipitate. We really can't see it, but it came from a biological origin. And there's a close-up of the shells in limestone. You see the shell impressions, and even some parts of it have shells itself. We have samples of this which you will see in person. Very exciting times we're living in. And then the last on the list is bituminous coal, which is different than the other coal you're going to see when we get to metamorphic rocks, and it's compacted plant remains. So this is a type of fossil fuel, which is a rock that we sometimes burn to make energy, electricity, or to keep a house warm, or anything like that. And you could see all the map symbols exist over here. If you ever get a question that has layers of rocks and it has these symbols, you'll be able to decipher and figure out which rock is which. Which brings us to our final shot of this pretty brilliant organization of information. Again, in the clastic rocks, the composition could be exactly the same. The only difference is the grain size. And if you look over here, the chemically and or organically formed sedimentary rocks, you can see grain size is a factor, and it varies from fine to coarse crystals. The compositions are listed here for you with the rock type. And if you look at the comments, crystals from chemical precipitates and evaporates. Evaporation leaving behind the precipitates, giving you these rocks. And they are sedimentary rocks. Sedimentary rocks are formed in water. That's very important for you to know. So if they ever say, oh, we know this area is once covered by a large sea or a large ocean, and you might ask, well, how do they know that? Because there might be a large deposit of sedimentary rocks, which we know form in water. And then the crystalline or bioclastic, so limestone could either be from precipitates or it could be from biological origin, in the case of the coal, from compacted plant remains. And of course, would screencast be complete without our two characters? We have to come up with names of these, by the way. Got to think of it. I also need a magic word that you need to know, and of course the only magical word I could come up with right now is Pembrella, because it is not only one of the most brilliant products of human accomplishment, but it's a good magical word too. So the magical word is Pembrella for this screencast. And you can see the dialogue occurring here. That was almost as brilliant as Pembrella, and of course the response from the astronaut is nothing is as brilliant as Pembrella. I hope you enjoyed this screencast, easy for me to say, and I will see you in school tomorrow. Enjoy your day. Enjoy your day.